Things affected by chance, like sum of dice, people's height, IQ scores, and actually income transformed using the logarithm, all have this bell-shaped distribution, either spread or thin. This is approximated by normal distribution, with Greek letter mu describing its mean, and sigma its degree of spread called standard deviation. But if we try to write down the probability density function, it's actually a monster. It has e, pi, and all jumbled up into a complicated formula. But no worries, let's go through the derivation of this formula. First, the basic formulation, second, the coefficient, and third, the details of its exponent. Imagine you're throwing a dart at a circle board. Given the same distance from the center, the larger areas are more likely to be hit. And given the same area, the closer regions are more likely to be hit. Remember that because it's circular, rotating this shouldn't change anything, but let's just pick some axes x and y. The first step is to explain why the basic formula is the exponent of negative x squared. Pick any point with coordinates x and y. If you consider the probability of a dart landing on this thin vertical strip, that's just fx times the width of the strip delta x. Same logic goes for y. Alternatively, the point can be described by polar coordinate using radius r and gradient theta. If you consider the probability of a dart landing on a square box, that's just some function of r times the area. But hey, this must be the probability of landing on x and y strips at the same time, which can be described by multiplication. Cancelling out the area and differentiating with respect to theta, we get fx dfy d theta plus fy times dfx d theta is just 0. Using the chain rule and polar coordinate representation, we have fx f-y x plus fy f-x times negative y must equal 0. Rearranging, we have that f-x over fx times x must be equal for any point x and y. Well, that's possible only if this value is a constant. Let's focus on x for now. Moving x, integrating. We get that fx equals some constant a times the exponent of x squared times a constant c over 2. Recalling that farther away from the center the lower the value of fx, we must have that c is negative. Now you see that this is a basic structure. Let's move on to the coefficient a and show that it's equal to 1 over sigma times root 2 pi. Because fx must describe a probability, the integral must equal 1. And because of the symmetric structure, you can just consider half of the domain and say it's 1/2. Moving the constant a, we know the functional form. But the thing is, we can't just integrate this. If we could, we wouldn't need the normal distribution table that's found in almost all textbooks on statistics. So instead, let's consider a joint normal distribution. Introduce y back, put them together, and use polar coordinate instead. Here's where pi comes into play. Using integration by substitution and using a new variable u equals r squared, we have that the left-hand side just becomes minus 1 over c times pi over 2. Well, that's just saying that a is root of negative c over 2 pi. So let's go to the last step describing the relationship between c and sigma. The variance, sigma squared, is defined like this, assuming that the mean is 0. Substituting what we already know about fx and using integration by parts, we see that the formula cleans up very nicely, and with the first part both equal to 0, and second part minus 1 over c times root 2 pi over 2 times root negative c. Well, it turned out that all these complicated things cancel out with a coefficient, leaving c equals negative 1 over sigma squared. Remember earlier when we said that the mean equals 0? Even if mean is not 0, we can slide the axis by mu to adjust it. Putting together, writing c in terms of sigma and shifting the mean by mu, we find the details of the exponent as we originally saw. In summary, the first step described the functional form, the second the coefficient, and the third the exponent. They came from how joint normality implies relevance of proximity but not rotation, and the fact that integral of fx has to equal 1, and adjustment of the mean and the spread. Now you know the derivation of this not so simple function behind so many natural and social phenomena around us.